Hello, everybody, and welcome back to a fun demo session of some new Ascend capabilities. For those of you who have seen a couple of our previous updates, you're now familiar with our new Flex Code connectors, which are super exciting. They give us the ability to really tap into a whole host of new types and sources of data, but also give us a lot of really great reusability of our connectors and our connections, so we can establish an existing connection to a database, really quickly browse and ingest that data and convert it into a really easy data set for us to go use. And in this example here, we're going to walk everybody through a bit of what it looks like to CDC data into the Ascend platform. So what you'll see me doing here first is grabbing a full snapshot of our database. And here we are using the DVD rentals database, doing a very simple example of just first get a snapshot. We're doing a full sync. Oftentimes you're going to do this full sync actually from maybe it's a backup that you already have in your object store, whether that's S3 or Azure Blob Store or Google Cloud Storage, or maybe you have us reading directly from the database itself. But first thing we do is ingest a snapshot of data. Now, one of the fun things you'll see as part of the Ascend platform, however, is a new connection type. Right here, we have obviously our standard database. We're grabbing just the standard actor snapshot of data. But one thing that we have also added is the ability to do a CDC style ingest of data. And what I can do here is when connecting to Postgres, I can actually say, I want a different replication style. I want to do CDC. I'm going to grab all of my CDC data from that Postgres database. Now, for those of you familiar with CDC, you'll recall it's slightly different than connecting to a single table. When databases have their change data capture, and especially Postgres with their log for CDC, what you're actually getting is a whole stream of changes from many databases and tables. And so what we'll end up doing is actually filtering that out for the specific table that we're interested in and we want to reconstruct in the Ascend platform. But so first thing you'll see me going through here is I've specified the connection details. I've actually had Ascend automatically generate the CDC schema for me, which is really quite handy. And here I can tell the platform, I actually want to refresh every 5 minutes, and we can dial this up, we can dial it back if we want, but 5 minutes seems, pretty okay for a CDC connection. So now when I connect this, we'll see Ascend is actually going to go in and tap into that CDC stream, and we're going to ingest a bunch of that data that we find changing inside of the database. Now, one of the first things that we'll usually want to do after grabbing this whole CDC stream is, more often than not, we want to actually filter that out, because we have to get just from the actors table, just the relevant pieces of information here that we want to join with our snapshot. And so one of the next things that we usually go through and do here is we'll go through and actually just create a Sql transform. We could do this in other languages too, but this seems reasonable enough for our uses here. And so I'm going to cheat. I have a copy, a notepad over here, but the SQL you'll see just to filter out some of these objects, it's pretty straightforward. We're grabbing the kind of replication data. If it's a delete versus an insert or an update, we grab different key values. And then we really just start to parse some of the data that's coming in from a CDC stream. And I'll show you that in a second. But let's create this. And you'll see this will start to filter out all of the data that's really just relevant for actors. Now, if we look at this data, and just to give you a sense of what the CDC data itself looks like, it's pretty straightforward. It comes in from the database. We usually see a kind of operation, insert, update, delete. You'll see a handful in here, the schema on the table of the database. And Postgres is pretty nice. They give you a handful of things like the column names, the column types. They can be helpful in downstream systems. And then a bunch of different column values. Obviously, I've been inserting myself with a variety of different names into the actors database, trying to get my 15 minutes of fame. And so we'll see all of the values here. On deletes, you'll actually see a bunch of the key types and values show up here once we start to delete things. And then this is actually some of the CDC data itself around the write-ahead log, change indices, and when we receive that data from the database. And that will come in handy a little bit later. So as we do that, we'll now see that we're running a bunch of processing jobs, and we're actually going to filter down the individual actor data from this whole raw set of data. Because in here, obviously, we have a ton of records inside of this system that already has 500,000 change records that we can go see. Now, while this goes through and finishes processing, however, I'll show you what that next piece looks like, because what we want to do now is we want to take all of the actors CDC data, and we want to go and compress that down. And so what we will do here is create a transform coming off of the two of these. Now, this is going to be a slightly different transform than a Sql transform. We can do some really fun stuff in the PySpark world here. And so let me show you what a PySpark transform looks like that's going to pull these two together. We're not going to get fancy with recursive transforms. There's a whole way of doing really neat recursive transforms on CDC, and at material size and scale would probably recommend doing so. But for our demo here, not really needed. So when we pick our two inputs, really what we're looking for is, first, we want to be able to grab that snapshot of data, and then we want to grab the filtered down CDC stream of just the actors data themselves. Now, from there, let's do a full reduction partition strategy. Again, we could get fancy and try and do some smarter partitioning here, but I don't think we really need it in this case. Now, inside of here, we see our PySpark transform. For those of you who have written the PySpark transforms before, pretty standard, helpful template that we see. But we're going to add in a couple of things here that just make this a little bit easier for us. So first thing I'm going to do is I'm going to add in a couple more imports. Really what I'm looking for is the window function here and some of the other PySpark functions that we'll see down here. Next, what I'm going to do is just going to rename a couple of these because it's easier for me. So we're going to get rid of these for a second, and I'm going to add in just a couple of data frame names in here. And then what we're going to do is create a new data frame. And this data frame that we're looking for here is, first, we're going to grab and create a core data frame of taking that actor snapshot, adding a couple of columns, because one of the things to note is we have some CDC columns in the CDC stream that we just simply don't have in the snapshot yet. So what I'm doing here is I'm just adding a couple of kinds of data replication. Obviously, anything with the snapshot is just a part of the snapshot. A couple of data start and change indices that basically say these are the oldest records we have. If anything on the CDC stream is newer than these, apply that instead. And then I'm selecting to actually reorder the columns themselves to make sure that the column names are in the same order as the CDC streams columns. And next, what I can do is simply union that with the CDC stream itself. And now I have a consistent data set of all of our records. Now, of course, this hasn't been trimmed down yet to just the records we're looking for. And that last part becomes really simple and easy and straightforward. Just a small bit of code here that says, let's grab that other data or that data frame that we just created here. And what we're going to go do is we're just going to create a row number. We're essentially windowing everything based off of that ID, that actor ID, the unique key that we know from this database. We're going to order everything by that, sort it by this data start and change index to get the newest record possible. And then all we do is we select everything that has that first row number. So we collect everything by the actor ID, order them in descending order based off of their change time in essence. Find the first one, remove everything else. Then what we're doing is we're deleting anything that has the kind of delete in it, obviously because it should no longer be there. And then we just select the last few columns that we are actually interested in that are reflective of that original database table. And that's it. And from there, we're able to create this CDC stream, apply it to the existing snapshot, and away we go. This will pick up in a second and start to process all of this data. And we'll see now not only our snapshot, but our snapshot with all of the CDC data applied as well. This will take a few seconds, sometimes up to about a minute, to compress and realign all the pieces of data here. And then we'll end up seeing our final database table here that will end up having not just this original snapshot that I took, but also a bunch of the CDC records that we have flowing through. And while that finishes, the last part I'll highlight here that becomes pretty neat is if you look at some of these record counts here, this starts to tell you and showcase the real power of that CDC stream, where our original snapshot only had 200 records. We have nearly 500,000 change records coming from the database, but really only about 680 of those change records are particularly relevant to the actors table itself. Yet, as we watch this flow all the way through to actor all, we'll see that get compressed down, and we're dropping records intentionally to get the absolute latest state of all of the records in that table. And so we'll see this as a finish, showcase the end there for us. Oh, and there it goes. We just finished, and we now have 399 new actors inside of this database, including all the famous ones, and hopefully my name down in that list somewhere as well, which gives me my 15 minutes of fame and hopefully completes our demo and introduction to Ascend powered CDC off of Postgres. Thanks everybody for watching. I encourage you to give this a try on your own. And as always, check out our free trials and ping us in our Slack channel if you have any questions at all. We would love to connect and help you out.